The ultimate vision for crypto is the engineering of the civilization of the future. So we need new systems for money and finance, but also media, science, governance, and more. But most of that stuff you can't actually build on Ethereum or the L2s. Blockchains are too constrained. They're like little tide pools disconnected from a whole ocean of hardware and software resources. Web 2 platforms like AWS allow developers to use those resources to build on those systems, but then anything you build there is centrally controlled. EigenCloud brings the decentralized, unstoppable verifiability of Ethereum to this ocean of resources. So then we can build truly civilization-grade software infrastructure. In this video, I'll explain how EigenCloud works. Note this video was made with support from EigenCloud, but as always, all views expressed are my own. At the center of our world computer, we have Ethereum, where program execution, smart contract execution, is backed by almost $150 billion worth of staked ETH. So this capital, this staked ETH, serves sort of as the foundation for the system which runs above it, for Ethereum itself. And this here is my depiction of Ethereum, or more precisely, this here is meant to be the world state. This is where all of the accounts and contracts live. And again, this is all backed by this staked capital. So with Ethereum, we have this super solid and secure smart contract platform. But of course, it doesn't scale too well. And this is necessary to maintain decentralization, but still it doesn't scale too well. So to address that, we introduce the L2s. And these L2s serve to sort of expand and extend Ethereum to give us this platform which is much faster, higher throughput, low latency. And these L2s also inherit, with some caveats, they inherit the security of the L1 of Ethereum itself. So this bigger, faster Ethereum platform is also very secure. Now, these L2s do introduce some fragmentation. You can see I've drawn them as these little islands, which are connected back to Ethereum, but also definitely separate from it. But this fragmentation is being addressed through various interop developments which are underway. So if we kind of zoom out and think of the big picture of what Ethereum is evolving toward, what it's evolving toward is this platform which is super fast, secure, and which, as the interop develops and proceeds, will increasingly cohere into a functional unity. The L1 and L2s become more seamless with each other, and we have the emergence of this singular unified world computer. Now, that sort of seems like the end game, like Valhalla, like the finish line, because, if you have this platform which is fully programmable, and then you make it fast, secure, good UX, and of course, under all of that, it's decentralized, verifiable, etc. If you achieve all of those things, then what more could you want? It seems like you've reached completion for this kind of paradigm, this kind of platform. And, that's true in a sense, but there's some nuance in there. So I said that this platform is fully programmable. In computer science terms, this is referred to as Turing completeness. And this is just where the logical sort of primitives that you have available to you are sufficient to construct any kind of logical mechanism. And this is a common property. It's common to most programming languages, most platforms. And it just means that the platform is fully general. Anything you could build on any possible computer platform, you can build on a Turing complete platform. So in that sense, this platform is complete. It is sort of perfect. But in practice, when you're actually building applications, there are some pretty significant limitations to this platform. So for example, smart contracts cannot reach out to the outside world. Your smart contract cannot grab the Tesla stock price from some web API. It can't interact with Visa and grab information and come back and do something with that information. It's sort of like this sealed off little computational diamond or crystal. This paradigm, this platform, is this place where computation doesn't happen very fast, but it is very precise and deterministic and reliable. It's like this little perfect space, so to speak, where in order to maintain that reliability and perfection, we kind of have to wall it off from the crazy, chaotic outside internet. So we can look into this little crystal. We can send transactions and trigger smart contracts from the outside in, but we can't have those contracts look out or reach out. And again, this is necessary, but it is a limitation. Now, another limitation is in terms of software. This paradigm has necessitated the creation of new languages. And what that means is that developers who are experienced with Rust and Go and other languages, they can't just come here and build stuff, right? They got to learn the new tools and languages. And it means that we can't just import the great software libraries that people have built and use them here. We, generally speaking, have to build, or we've had to build everything kind of from scratch. So that's a limitation. Another limitation is in terms of hardware. So these systems, generally speaking, run on a more or less homogeneous set of general purpose computer hardware. They cannot lean on the different kinds of special hardware for special purposes. So for example, if you had a smart contract and you wanted to do AI inference, maybe you're building a decentralized insurance system, and you want to do some AI inference to adjudicate some claim. You really can't do that on these systems because that kind of computational work is far too intensive for general purpose hardware. You really need to do it on special purpose GPU cluster kind of hardware. And so it's just not practical on this system. So that's a limitation. The hardware is very constrained. And so if we compare these limitations to platforms like AWS, which is a Web 2 platform for building applications, AWS is much more open in a certain sense. There's no such restrictions. You can use whatever kind of software you want, any kind of hardware. There's GPUs, there's trusted execution environment machines. There's this massive range of different hardware configurations, and you're just not limited in these ways. And if you're not familiar, AWS and platforms like it have been a massive accelerant to the software revolution that we're in. They made building applications way easier and scaling applications way easier, and therefore we had this massive Cambrian explosion of applications. Now, what EigenCloud is doing, or is aiming to do, is to sort of merge the best of both of these worlds, to take these Web3 properties that we care about, decentralization and verifiability, unstoppability, to take those and apply them to a much more open, wider landscape of hardware and software configurations, and generally unrestrict these applications. So developers can build brand new things that couldn't exist on this paradigm. So with EigenCloud, I think we'll see a similar Cambrian explosion of new applications. Now that we have a sense for what EigenCloud is trying to accomplish at a high level, let's think about how it works. So it's useful to first think about how Ethereum works. And Ethereum essentially runs on this decentralized set of validator machines spread around the world. And these machines are responsible for keeping the system running. So their tasks include the proposing of new blocks, the attesting to, the voting on of existing blocks, and therefore resolving of forks. And they also participate in the finalization of sections of the blockchain, etc. And in order to ensure that these guys do this work properly, we require that they put up some capital, right? 32 ETH or more. They stake this capital, and then if they act dishonestly, they can be slashed. If they do the work properly, they earn some income. So there's this obvious crypto economic incentive that keeps these guys doing the work properly and this whole system running properly. Now, one way to think about the work that these machines are doing is that, they're just running software. They're running an execution client and a consensus client. That's Ethereum. They're just running the Ethereum software. And so what EigenCloud allows for is for these machines to opt in to running additional software, to doing additional work alongside their Ethereum tasks, basically. So these computers, these machines, can opt into running what's called an AVS, an autonomously verifiable service, which is similar to doing the work of keeping Ethereum running, but it could be anything. It could be the generation of zk proofs. It could be doing AI inference. It could be the resolution of prediction markets. It can really be anything. It's this open landscape where AVS developers can build a system and offer it up to these validators, to machines around the world, as sort of tasks that they can work on and therefore earn some income. So this core functionality, the ability to restake your ETH, run an AVS system, and potentially be slashed if you act maliciously, this core functionality is now referred to as just EigenLayer. And this part of the system is implemented as smart contracts on Ethereum that enforce the slashing of malicious AVS operators and so on. And if you want an explanation for how those smart contracts work at a high level, I did a whole video on EigenLayer before it was expanded into EigenCloud, where I explained that. So again, this is the foundational part of the system. This is EigenLayer. But now the system has been expanded greatly to include multiple other components, and we have EigenCloud. The first component that I'll explain here is EigenDA. And EigenDA is an extremely high throughput DA system. It's a data availability system. And if you're not familiar with what DA systems do or what they're used for, you can think of DA systems sort of like bulletin boards or Dropboxes for data, where the data posted there is made highly available. It should be very easy for people who want the data to download it, and it should be very hard for people who want to censor the data posted there to do that. It should be this sort of unstoppable Dropbox. And data posted to DA systems is not stored for like many months or years. It's stored for like 2 weeks or 3 weeks. And if you want an explanation of how EigenDA works specifically, as well as Ethereum's DA, its blobs, I did a whole video on that, which I'll post somewhere. Okay, so what are DA systems used for? There's many applications in all of crypto that rely on DA systems. So for example, optimistic rollups need to make sure that their transaction data is available to anyone who wants it, because people need to be able to make fraud proofs if they see the rollup has, reached some state that is incorrect. They need to be able to assemble all of the relevant transactions that would in fact lead to a different state to prove that the state being advertised is incorrect, right? The next component of EigenCloud to talk about here is EigenVerify. And what EigenVerify does is it offers slashing as a service, because it turns out that one of the hardest parts about building an AVS system is actually in writing the slashing logic. So for example, if you imagine you're trying to build a decentralized AI inference system, what that might look like is you have your set of AVS operators who've opted in to participate in this system, and you distribute to those operators the inference tasks that you want done, right? So here's some input. I want it to be run against some AI model and then return the output. Now, to make this system work properly, you of course need to be able to slash those who do this work incorrectly or even sort of maliciously. And how do you do that? In the case of AI inference, it's actually not so simple, because you can't just put it to some smart contract and say, okay, here's some task that was done. I think it was done incorrectly. Here's smart contract, take this work and figure out if it was done incorrectly. Because the only way for the smart contract to do that would be to re-execute the inference. And that is far too much computational work for a smart contract to do. Another idea might be, well, we could do like a zk proof that some task was done incorrectly. But that too is not easy. You can't just arbitrarily make zk proofs of whatever you want. You have to build up like a zk circuit that is equivalent to the computational work and create the proof with that circuit. But these AI models, again, they're very large, so doing a zk proof circuit for them is really hard. What EigenVerify does is it offers a solution to this. It allows you to just plug into EigenVerify, and what it will do is re-execute your task and determine whether it was in fact done incorrectly or not. Now, EigenVerify can handle 3 different categories of dispute resolution. The first and simplest is objective computational work, where there's a specific, precise answer. And this is easy to resolve. The system just re-executes the code and sees if the answer it gets matches the answer being proposed and disputed. Another category is intersubjective tasks or questions, where there's not really an objective answer, but it's not subjective either. An example of this would be the result of an election, right? The answer to what happened cannot be determined by running some code, but it's not subjective really. Any two reasonable people can agree on what the outcome of the election was. So EigenVerify can resolve these disputes by putting the question to EigenToken holders, and EigenToken holders can vote on what the truth actually is. And in the probably unlikely case where the EigenToken holders collude to advance some incorrect result, the wider community can see that and, in the extreme case, fork the token and thereby slash those colluding token holders. And there's incentive to do this because, if you're a token holder and we slash the balances of these colluding people, then your tokens are worth more. So there's this very strong incentive for these token holders to act honestly. Another category is sort of AI-assisted adjudication, where the question or the task is a little more subjective. So for example, if you imagine you're building a decentralized news aggregator system that categorizes news articles based on left or right bias, on the quality of journalism, whether it's misleading, fake news, whatever, that's pretty subjective, right? So if we have some alleged miscategorization and we put that to EigenVerify, what it can do is it can put the question to an previously agreed upon set of AI models, right? So we can have a sort of council of maybe 3 AI models that will weigh in on the alleged miscategorization and give their determination. And maybe we take, a majority, a kind of best of 3 judgment, and we just consider that to be the truth. Next up, we have EigenCompute. And what EigenCompute does is sort of similar to EigenVerify in a sense, in that it abstracts away a lot of the complexity of building an AVS system. But where EigenVerify abstracts away the dispute resolution, EigenCompute will abstract away a lot more, basically everything except your core logic. So if you imagine trying to build an AVS system, there's a lot of overhead you need to think about. It's not just about your core, defining your core computational tasks or whatever that you want the network to do. You're also going to have to take that and package it into an application with some communication overhead between nodes and a bunch of other stuff that allows the thing to work as this cohesive little network. And you're also going to have to, bootstrap the network itself. You're going to have to convince these operators to run your system and get it to some kind of minimal viable size and so on. And EigenCompute will abstract all of that away. And so it's this platform, it's this place where you can just deploy the core application logic you care about and just have it distributed to this existing set of EigenCompute operators. So you don't have to bootstrap the network, you don't have to worry about any of the overhead. You just deploy your basic logic to the system and it will execute in a reliable way. And finally, the newest addition to EigenCloud is EigenAI. And what EigenAI does is it provides verifiable LLM inference infrastructure. So it provides verifiable AI. And I did a whole video on the importance of verifiable AI, so watch that if you're interested. But long story short, as AI gets more intelligent, which is happening rapidly, we're going to increasingly use it for more important things, right? It's going to be used increasingly in the running of companies, in making decisions on how to manage the economy, right? And it'll have more autonomy over time. And ultimately, I think it will be used in government. We're going to lean on these AIs to run our world, our personal lives, the economy, our countries. And, that is just really not possible without a verifiable AI. Because if you're just shipping off your prompts and the tasks you're giving to your AI, if you're just shipping that stuff off to OpenAI or Microsoft servers or whatever, you have no insight into what's happening behind the scenes there. It's a black box. They could be altering your prompt a little bit. They could be altering the output. They could be redirecting your prompt to a different model than what you expect. they could be altering the model in a subtle way that perhaps biases it against whatever you're trying to do, right? And to say a little bit about how EigenAI works, what it does is it offers access to frontier open source LLM models like GPT OSS 120 billion released by OpenAI. And in order to provide these models in a verifiable way, they found a way to do deterministic inference. So if you're not familiar, most LLMs are actually kind of non-deterministic. There's this internal temperature setting, which adds this non-determinism, this bit of randomness to the inference. And there's also these deeper underlying factors which contribute to the non-determinism of the models. But this non-determinism makes it really hard to do verifiable AI, because if you think some output was kind of tampered with, you can't just re-execute the inference using the same input, the same model, and see if you get the same result, because each time you do some inference, it's a little bit different. So what can we actually build on this platform? The first set of applications I'll talk about is with AI. And I mentioned EigenAI, and I think one way to think about what this service does is that it sort of offers access to verifiable AI brains. Now, what we do with those brains can be just about anything. You can imagine AI agents that trade stocks, that run a DeFi hedge fund or something, or that start online AI managed companies. That's probably not too far away. Once we have verifiable AI, we can start to do some really strange and interesting things, not just in the domains of science and technology, but also in the domain of culture. So imagine, for example, we set up a verifiable debate market. So there's some debate upcoming between two political influencers, and we allow people to bet on the outcome of the debate, on who will win in a prediction market. Then when the debate is concluded, we feed the video or audio, text, whatever, to AIs, and they can weigh in and determine who won the debate. And, you know, that becomes this really interesting almost sport or something, where debate becomes this thing people bet on. We have this somewhat objective way to adjudicate the results. And you could also do some really interesting other things, like maybe you have AIs fact checking in real time, super fast, as the debate happens. So then we can see like a tree kind of emerge on the side of the screen, showing how this particular point that is made is rooted in fact or not, etc. And, you know, I think this gets into really interesting territory, because we can imagine other similar applications where maybe we take AIs and we have them parse through our history. We have them parse through what is taught in the schools or something, and sort of give this somewhat objective judgment of how accurate our accepted history is. Maybe they can say, look, this event here is vastly understood. It's not understood well enough. Or this is overemphasized. Or this thing here would be super valuable for these people to understand. There's just a huge amount of applications that open up when you think of how you can apply AI to cultural questions, not just technological questions. One of the most interesting potential applications here to me is verifiable decentralized science. So it seems to me that the scientific endeavor has stagnated significantly in recent years, and there's actually good evidence to support this. But it seems that the university system is so bureaucratic and dogmatic that the tree of science, so to speak, has sort of withered and stopped growing, or even started to die a little bit. And I think with verifiable decentralized science, we have a chance to break away from that system and to breathe new life into this tree of knowledge. And of course, the potential impact of this would be tremendous. If we can break new scientific ground and make new discoveries, that can be world-changing. And, you know, the way that we can build something like this on top of EigenCloud is we can set up sort of verifiable signals from scientific instruments. We can independently fund scientific projects. And I think more broadly, we can design economic incentives which allow for the flourishing of scientific discovery, of heterodox thinking. We can set up a rich soil, so to speak, that nourishes that tree of scientific knowledge. Next up, we have zkTLS. And I did a whole video on zkTLS, so watch that if you want the full story. But the basic idea is that with zkTLS, we can import data from the Web 2 world into Web 3. So maybe you want to prove to some DeFi protocol in Web 3 land that you have some amount of money in your bank account in the Web 2 world. You want to prove that you have at least X amount of money. And then maybe the DeFi protocol will give you a uncollateralized loan. There's a lot of potential in zkTLS. It's a way to kind of bridge these worlds. The Web 2 world is really big, right? There's a lot of these centrally controlled institutions that kind of run our world. And Web 3 is comparatively actually kind of small. So if we can create a bridge to bring that stuff in, it's potentially a huge accelerant to this whole revolution and can allow us to improve a lot of different systems. I'll just mention a few more here. We have verifiable casinos. So there's sort of casino style games on Ethereum and the L2s right now. But with EigenCloud, you can do much more rich and complex stuff. You can allow people to bet on all kinds of different things. We also have Oracle systems, verifiable databases, and another one I'll mention quickly is the idea of meritocratic meme coins. So Sriram tweeted about this, and the idea is that, with networks like Ethereum and Bitcoin, the people who contribute to the security of the system, the miners, the stakers, they are rewarded. With meme coins, you don't really have that. People who contribute to the strength of the meme, they don't get anything for it, right? So this is something you could pioneer with a platform like EigenCloud. You could build a meritocratic meme coin where those who propagate and strengthen the underlying meme are rewarded with additional tokens. The final point that I want to make here is that when you have the creation, the invention of a new kind of computing paradigm, which EigenCloud is, where you have full generality, full programmability, you have this open paradigm. When you have such a thing, you should pay attention. And I'm reminded of when I was in school studying computer science and I discovered and understood Ethereum. I remember reading about the fact that Ethereum was Turing complete. And immediately I was like, okay, I'm all in. That's all I need to hear. Because if you have a platform which is fully programmable, Turing complete, fully open, and you can bet on that, then what you're betting on by proxy is like this infinite expansive universe where the most intelligent and inventive people of our generation and subsequent generations can build whatever they want, right? So if you can bet on that, you're betting on like the human spirit itself almost. So that to me was a pretty easy decision. And, I think EigenCloud might be similar to that. It's this open platform. It has these properties of full programmability and so on. And it has a different set of constraints or properties compared to Ethereum and the L2s. In many ways, like I said, it's more open. It's more expansive. And when I think of the true potential of these systems, what I see, like I said in the intro, is the potential to re-engineer our civilization. And that to me is the project of the 21st century. We can and now must re-engineer our civilization. We need to build a parallel civilization with new institutions for doing science and media, history, social media, sense making broadly. We need to, harness AI in an intelligent way. And ultimately, we need to work our way to the top of the pyramid and think of new ways to structure and govern our societies. Perhaps something along the lines of Balaji Srinivasan's network states, right? We need to build a new civilization. And to me, it's time to do that, because we have the opportunity now to not only, in my opinion, radically improve the conditions and creative output and, Promethean energy of the Earth, we also have the opportunity to expand into the stars and create the foundation for the kind of civilization that can actually do that. So to me, this is the project ahead of us. Okay, thank you for watching. The next videos will be on interop zk, and I have like 7 more that are ready to shoot, so watch out for those. And yeah, thanks for watching, and see you next time. Peace.